Up next, we're talking to Asya Kamsky, who is the principal engineer at MongoDB. MongoDB, of course, is one of the innovators in the NoSQL movement and a document database provider. Welcome to the Next Database Platform.
Thank you.
So I want to start in an obvious place. There are a lot of databases that people can pick to do things these days. There are quite a number of document databases. There are document extensions to relational databases. There are all kinds of interesting things that people can pick. What is the reason why people should choose a document database in the first place?
Well, first of all, I'm going to say something that maybe our marketing and salespeople are going to hate me for saying, but I always say this. There's not ever a single right tool for the job, right? There are wrong tools for the job for sure, right? If somebody needs a database and they're storing their data, on disk in flat files, it's probably the wrong tool, right? If they have very basic need for, I just need to persist some data and quickly get back some subset of it or even all of it, all kinds of things can be completely 100% perfectly fine and adequate for the job. I think the place where we get stuck is where we think that for any given single use case, there's one single best tool to get the job done. And that's not really true. I actually have worked with relational databases for years and years and years, like literally, 15 years or so. And I've worked with a lot of them. One of the reasons that I personally, like when I first tried MongoDB, was like, hey, this is cool, is because I had my firsthand personal experience trying to make a relational database do something it was never designed to do to begin with. And that's really the sweet spot, is when you go, oh, what's easy in this database is the thing that was really, really hard in that other database. You go, this database must be better for that type of thing. And then that type of thing includes a whole lot of different things, right? Details and whatnot. So which way should we dig into more details from that, answer?
Yeah, I guess my next question would be, the big relational databases of the world, I call them the incumbents. They have JSON formats they can put inside their databases, and Oracle came around a couple of years ago and added them as well.
They did.
I'm talking about DB2 and SQL Server are the main ones I care about. There are others, of course, but where do you hit a tipping point where you say, that's not really working for me? I need to get an actual proper document database for this application. Where is that tipping point, and how many people hit it? Is it something that everybody's going to eventually get to, or is it something that only those operating at the most extreme scales are going to get to? And that's where you capture them as customers.
Yeah, I think scale and how big an application might be is kind of orthogonal in my mind to the data model, right? Your application could be really small and in no way ever require partitioning or global clusters, right? Replication and high availability is different, because I think that every application that's in production needs that, right? Any application that can't afford to be down, for whatever your definition of down is. But the data model is essentially how the application code relates to whatever it is that your data store is, right? And if you have blobs with primary key by which you fetch things, right? A key value store will do. And even in the days of relational databases, you might think like, well, that's the simplest data model. I just have my primary key and then a blob. And relational databases have let you store arbitrary blobs for a really long time. Like,
yeah, but they had really terrible performance in most
cases.
Yes,
they did, which is why
that's what I'm saying. You gotta think about it,
Right. So key value stores came along and said, oh, we can give you like super fast performance, because essentially everything is optimized for, you store stuff by primary key, you fetch it back by primary key, right? And you get your whole payload back, but you can't ask questions about it. You just bring it back application side, and then you do whatever you have to do with it. MongoDB, this was in the late 2000s, right? There was this gap, right? You have the relational databases, and it was very painful to make the relational database store unstructured data. It was difficult to make it store data that evolved really fast. I forget
and it was doubly painful because you had to pay for it too.
But we won't even go there for the moment, right? Because, different, there's free and cheap options for everything. Was it free, cheap? No, cheap, fast, correct, pick two. Was that it?
Right.
So essentially, the founders of MongoDB had used relational databases extensively in their previous jobs, companies, products, right? And they always had the same problem, which is, quick, we got to change something in the schema, right? We have to start storing new fields. And now, if you're using a relational database, what do? Do you create a new field for it that you can index and query by, or do you stick it into the blobby? Or, there's still relational databases that say we support JSON, but they basically store it kind of like a blob, right? It may be a text blob, or it may be some kind of an indexed text blob. But, at the beginning, it was just like, oh yeah, sure, you can put JSON here. But if you really want to efficiently query on it, you should pull that out into real columns, right? And they kind of wanted to be able to have a document be the first class citizen in the database, rather than that being a row, where a row or relation is defined as having these exact fields. So the idea was, how do we make document the first class citizen, but retain the ability to build indexes on any field, to query by any field, to have queries that are not just equality or ranges, but complex queries, right? Like essentially so that when people are moving over from relational to a document database, they don't have to give up how they query their data. They just give up the part that would horrify me back in the days when I was a data architect and DBA for relational databases, which is they just give up the schema, right? Which of course ends up with garbage in, garbage out. And I tell people that the document databases, they're not schemaless, right? They just don't enforce the schema. Now, you can enforce schema optionally, right? MongoDB has schema validation and JSON schema format. There's all kinds of ways of telling it that you want certain fields to always be present, that you want them to always be a particular type, but it's optional, right? You could just say, I'm going to put whatever documents in, and I'm not going to have any constraints on the data. And I'm going to deal with the cost of that when I'm fetching the data, which of course means your writes are going to be super efficient and fast, and your reads are going to get more and more complicated and less efficient.
Because you've got to write some logic in those reads to make sure you're getting the right stuff out of it again.
Right. We always tell people it's like you got to pay the piper sometime, right? You either pay the cost at writes or you pay the cost of reads. You either pay the cost of design of the data model or add more complex code later if you don't have a understood design, right?
So what do real users do when they face that situation? So, my next question was, a lot of these things are starting, a lot of transitions in IT start at the top. We're moving to SAP, therefore we're moving to Oracle. It's that kind of thing. With Mongo, it's the other way around. It's the developers like, I am so sick of schemas and managing this garbage. I just want to write an application, please. And I'm paraphrasing.
No, but it's actually very accurate, right? What we hear is similar to that. And I started working with MongoDB in late 2011, maybe. My first attempt was, I was working on some little project on the side of my real job. And I was like, oh, MongoDB, I don't know what that is. I'm curious.
Sounds big.
I'll download it. No, it sounds humongous, whatever. I'll use it. And it was basically to just move some data, reformat some data and put it into another system. And I used Python. I installed PyMongo, which is the driver where documents just show up as dictionaries, right? So there was no mental disconnect, but I did have to figure out how do I want to restructure them to put them in the new system. And at the end of this less than a week project, I was like, wait a minute. I didn't learn anything about MongoDB because I never had to look under the hood or tune anything. And later what I realized was, oh, actually what I learned is why developers are so passionate about being able to use it, because it just stays out of their way. And I mean, luckily I've worked for startups for forever and ever, right? So I'd be like the data architect, and then I would take that hat off and I'd be like the backend developer, right? And then when it was time to launch 1.0, I'd be like, you know, the support and debugging why the database isn't performing well. And
so you don't get any vacation this way. You realize that, right?
Right. And then yelling at myself going, you know, why did you, you know, structure the schema this way? This will never scale, right? And so I totally could understand coming to it from the point of view of a DBA going, what are you doing? Like, how are you going to, you know, tune this? But coming to it from a developer standpoint, it'd be like, oh my God, this is so simple and straightforward. Right?
So that circles us back. Like, so when they have to make that choice between using those optional schema methods or doing it programmatically as part of their reads, what are people really doing?
Well, hopefully they're doing the right thing, which is after doing a first iteration prototype, they go, okay, I still have to know what the objects that live in the database in different collections are. And so what happens is they have to, I mean, you know, it's really kind of a lot of it is about engineering discipline, right?
Right, but you got to go back and put some schema on it sometimes is the point.
It's not necessarily schema. I mean, think of it this way. If you have a strongly typed language versus not a strongly typed language, it doesn't mean that you're going to put a bunch of strings, numbers, and other things into a field in your class, right, in an object in your code. Like, just because you could put different types into it doesn't mean that you will. In fact, usually you won't, right? Mm-hmm. But you might switch from like an int to a float at some point. And if you're using a weaker type language, there are no consequences to it, right? Numbers are still going to compare as numbers. And if you're storing them in a database where they're all numbers, you know, your queries are still going to work correctly, right? It's only if you go, oh, instead of storing numbers here, I'm going to store a string that says 5 in it. And then you have to change your code everywhere because you can't compare it to a numeric and you can't do range queries on it the same way anymore, right? Mm-hmm. So I actually think that what ended up happening is things that users already had to do in their code just, you know, automatically would work with the backend. And I kind of feel like, you know, and I hate to say it because I've been a DBA, right? Insisting that people be very rigorous about, you know, their various, you know, schemas and logical schemas, physical schemas. But most of the time, at the end of the day, the developer didn't do anything different except that they just had absolutely no visibility whatsoever into how the documents were persisted, how their objects were persisted inside of the storage layer. And I think that if developers aren't going to think about the storage layer, which they never ever want to, and I don't blame them, I would rather them not think about the storage layer that's storing objects that in some way look like the entities they're interacting with in the code. I think they're less likely to do something really horrible, you know?
All right. I get it. I'm going to move on to the next thing.
Sure.
So a lot of, I would say every database vendor has to have some sort of cloud strategy. And I would also say that with MongoDB, at this point, you're a cloud first strategy with Atlas, and then MongoDB Enterprise gets the goodies after they've been tested out there on the cloud. So talk to me about how, you know, that shift happened and what does it mean?
Well, I think one of the reasons that the shift was a little bit easier than it might have been is that replication and sharding, which is, you know, essentially high availability and partitioning, were built into the product in like version 1, way from the beginning, which means that from the beginning, the server itself wasn't a single monolithic server, but it was a cluster of servers where there was an understanding that as your data grew, you would partition it across different servers, and some of the servers would act as secondaries or replicas for other servers, because the fact is that when you have dozens or hundreds or thousands of servers, some percent of them are always going to be dying, and you want another one to take over for it automatically. I think the fact that that was fundamentally part of the architecture made it so that the distributed cloud, the whole out there world system that spans anywhere in the world, was part of the basic building blocks of a MongoDB cluster. right? I mean, I remember working with, a giant monolithic single database server, right? Where what does it matter if it's in the cloud or not the cloud? It's just, it's in somebody's data center or it's in my data center, right? But the fact is that you couldn't take advantage of the fact that the cloud is actually an infinite number of servers at,
That's right.
Nearly infinite number of locations, right? And when you have a single monolithic server, frankly, I'm not even sure how do you turn it into a cloud service, right? Whereas something that fundamentally,
you have to be the vendor of the system that runs that cloud, runs that database, like Oracle or IBM, and you've got exactly the same limitations.
Right. Exactly.
there's no infinite scale inside of a Power 980 or an Exadata, whatever.
Right. I mean, there is, as long as you're willing to stay in that one little place.
Oh yeah, just in that box. But I'm saying
pay a lot more money and pay a lot more money. Yeah.
Absolutely.
So yeah, and so I think that, and I don't know if you know MongoDB history. Originally, our founders were not building a database. They were trying to build, and this was like 2007, 2006. They wanted to build an app development platform. So like what Google Apps became like a year or two after. They were just a little before their time, I guess, because people were like, oh, yeah, I don't think so. But the storage layer that you're building, that I'm interested in, right? It's like people weren't thinking that they were going to put, but they were thinking like, oh, well, my app has to talk to the single monolith. Like, I mean, even from like the late 90s, right, the .com days when I worked in a pretty big .com company, right, we had massive number of web servers, and we would add more as we needed to add more, and then we would add more app servers behind them, and they all had to talk to a single giant monolithic $1 million database.
Like, it was great if you were Sun Microsystems and Oracle. It was a wonderful time.
we used Informix, actually, because that was before the times got bad for Informix. I'm a big fan of its technology, by the way.
It was a great database, yes, and IBM bought it, and then we never heard from it again.
Yeah, it had some business issues, I think. Let's just leave it at that.
So I want to ask the last question here. So
sure.
Look out 5 years and then 10 years from now, what percent of the possible databases or storage, or I don't even know how to ask this correctly, but I'm going to try it anyway.
Yeah.
How much of it is in documents and in document database? How much of what we are doing in the data center naturally belongs in a document database?
So I'll preface my answer by saying I have absolutely no idea, so I'm going to make something up.
I'm fine with that answer.
Because I'm also going to tell you that anybody who does know is lying, and they're also making it up. But if you think about, I don't know, was it about a decade ago that Hadoop was like a big thing? It was all because people had a lot of data, and they were just like so worried that they were going to not get some useful value out of the data, right? So the idea was just keep collecting all of the data you have, and we'll somehow figure out how to get
it was supposed to be MapReduce and then SQL, and it ended up being cheap and deep, the cheapest and deepest storage, and that's all it really was. And then they still haven't figured out how to use it yet.
Right. And so meanwhile, people have been putting their data into some kind of data lake. I like to call it data swamp, because nobody actually wants to go into it, because who knows what's in there. But if you
wait long enough, it turns into oil. I'm just saying.
Oh, now there's a business opportunity. Yeah. Okay. All right. That's good. Yeah. If you think about the format that the data sits somewhere out there in, a lot of it is just in whatever format it was collected from the source. And a lot of those sources are spitting out JSON documents, right? Because when the data is coming from a data pipe, right, it's describing events, it's not normalized. Nobody has put it into third normal form to stick it into a database, right? It's coming in as events, entities, events on entities, but they're mostly like, even if they're not self-contained, they still represent an object that represents some kind of a thing. And that thing is never going to be tabular. It's just, I mean, it might be coincidentally, but to me, everything that's stored out there will absolutely naturally fit into a document. Now, they may not be documents that you can write a really good, efficient application against. You might need to restructure the data, right? Or decide like, okay, these things should actually be stored together and these things probably shouldn't be stored together because we have too much stuff repeating. But the fact is that anything can fit into a document. Not anything can fit into a flat tabular structure of a relational table, right?
That's a very, very interesting answer. I have to leave it there, but I like that answer.
I mean, you know, the fact is, one of the things about a document database is it's going to be good enough for almost every use case you have, right? Mm-hmm. But it's not specialized, right? It's not like a specialized data store that picks like a really narrow use case and like everything, as long as it's that use case, it's perfect. Mm-hmm. For like, you know, it's like document databases, it can be good enough for almost every use case. It can be the sweet spot for maybe, you know, 50% or 70% of them, right? There's a lot of specialized databases that you could essentially emulate what they do with documents just by structuring documents and indexing them appropriately. And it's going to be, you know, 80% good enough, 20% of that, or 20% good enough, 80% of the time, who knows, right? And ease of use and developer productivity to me makes up for so much. Mm-hmm. that you know, it just makes sense. Like the data is already stored there in documents. Well, see if you can just use it as is, because it's a lot of effort to transform it into a specialized format. And I think documents are generic enough that they're not a specialized format. They're just, it's like, I think it's what we thought XML would be way back when, right?
Yes. But
nobody could read it. And JSON is just so much more human readable that, you know, go buy XML, hello JSON, and now all data is transferred and exchanged that way, and it can just be stored in a document database. So there we are.
Very good. I have to leave it there. Okay. Thank you so much for participating, and we'll talk to you again soon.
My pleasure. Thanks a lot for having me. Bye-bye.